Hello friends, good morning. Welcome back to our channel where we talk general and electrical aspects.
In today's web interview, we have Mr. Nanda with us. He is an electrical engineer. He is working in substation, primary engineering. So he has good understanding about all the things in the substation, lightning arrestors from LA, from CB, and then CTPT, and all the bus bar arrangement, and some protection systems, and all the interconnections and everything, some interlocking schemes, everything he is very much clear about this, all the things. So we discussed most of the topics in a detailed manner, and along with that he has experience of MEP also, mechanical, electrical, plumbing also. So he explained about that profile also briefly, what they will do, what are the activities involved, what are the detailed tasks they are doing in MEP and all, who are eligible for MEP. Everything he explained in a clear manner. I hope this video will be benefit to many people, many professionals who are in electrical industry. Yeah, it is not only for electrical, but all the people who are interested to know about the substation and all, how it will operate, what are the key parameters and all. So it is for them. So you guys all can watch this. So it may be lengthy, but try to watch up to the till the end so that we can get better understanding of what the substation is. So different types of substations, we discussed it, what is substation, and indoor substation, outdoor substation, converter frequency. So many substations are there, what they will do, indoor, outdoor, GAS, when we will go for GAS and all, some altitude clearances, everything. So many stuff we discussed. It's difficult to say in a small 1 or 2 minutes, so it's better you go and watch it. If you're watching this video for the first time, please subscribe to my channel so that you don't miss any of my future updates. If you want to be a part of these web interviews, then please message me, or comment me so that I can contact you, share the now for knowledge sharing purpose. So thank you guys, keep watching. Yes, nice.
Yes. Okay. Thank you. Thank you. And good morning, sir.
Yeah, good morning, good morning. Welcome back to our channel, ALP Talks. Good
Okay.
morning.
Thank you, sir, for sharing, for inviting me. Thank you, sir.
Yeah, happy to see you. Yeah, you have
Uh,
very huge experience. Today we are going to discuss so many topics. Yeah,
mhm.
yeah, Nanda, as we already discussed, just to share my knowledge on electrical and things, I started this YouTube channel. So, yeah, I think you might seen some of the videos and all. Hmm. Yeah, nice. So it's your turn, dear. We want to know a few things about you, your educational profile, your professional background, so that
Okay.
we can dig into our topic. It's your turn, dear. Thanks for accepting
Okay.
and presenting here.
Most welcome, sir. Actually, thank you for inviting me. It's
Yeah.
a great pleasure for me for such
Mm.
a inviting for such a sharing my knowledge. Okay.
Yeah.
I am Nandadulal Manna. Presently, I am in Delhi. And
Yeah.
I have completed BTech in electrical engineering from West Bengal University of Technology.
Mm-hmm.
I have more than 6 year experience in electrical design,
Yeah.
and 3 years is substation design, and remaining
Mm-hmm.
part is the MEP design. And presently, I'm work at Utility Power Tech Limited, which is the NTPC and Reliance joint venture organization,
Mm-hmm.
and my native place is West Bengal. Today we are discussing about the substation design.
Yeah. Very nice, very nice. Nice to see you. Yeah, I hope our discussion may benefit many people who are in
Yes,
the
yes,
industry, because many
yes, yes.
people are designing individual components or using individual component. As a whole, substation means that is the heart. Everything is getting assembled there. I mean, transformer, all the circuit breaker, all the components which are there in the
Yes, yes.
manufactured at different places. Yeah, we are brought in to one place.
All equipment are in one place
Yeah.
in substation.
Yeah. In substation, we can see many components
Mm,
and many items.
mm,
Yeah.
mm,
Yes.
yes, 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 yes.
Yeah. Okay.
uh,
Okay. Yeah. Before going into our substation part, I think you experienced MEP also. So
yes, yes, yes.
yeah, can you explain a few things about MEP and all what you did, what's your experience, and what's your work culture, what you will do generally,
Okay,
so that after that we will move into this part. Yeah.
okay, okay.
Mm-hmm.
Uh, Actually, in MEP design, there is the in electric. The MEP means mechanical, electrical, and plumbing. That's
Okay.
called MEP.
Mm-hmm.
MEP. And
Yeah.
most of the actually buildings provide the MEP services. In
Mm-hmm.
MEP services, in electrical part, there is the most of the part is the LV system, and
Mm-hmm. Mm-hmm.
there are prepare for MEP design for preparing the lighting layout, power distribution layout, SLD, auxiliary transformer sizing, DV sizing, and also
Mm-hmm.
lighting calculation have required for MEP design. And
Okay.
MEP sector, most of the presently, hospitality and complex are required a MEP design engineer or other MEP design engineer, because they have planned the architectural, they have given the architectural drawing, and you can, and in electrical part they have put the lighting layout, they have put the power distribution layout, they have where is the where put, and also finalize the equipment, like transformer, DB,
Mm-hmm.
they have
Mm-hmm.
on sheet, the MEP design engineer have the selected part.
Okay. Okay. Mm-hmm. Yeah. So
That is the basic thing. Mhm.
yes, 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 yes. So generally, is this electrical graduates or any mechanical graduates also will be taken for this position, MEP? What you say?
Yes, yes, mechanical, electrical, both.
Both
Mechanical, electrical, both, and civil also.
civil
Because there are
also.
no actually, uh, there are
Mm-hmm.
not. Sorry to say that, not required a core engineering electrical. Sorry to say that,
Mm-hmm. Yeah. Huh?
because you have a knowledge, some knowledge, so you can go. A mechanical person also can design the electrical design in MEP sector.
Yeah. Yeah.
As per
Yeah.
as per my
Yes, yes,
knowledge.
yes, yes. That's
Uh,
what I'm asking because those are little bit similar things only, not
Actually,
that much complex.
okay.
Yeah,
That's
with
not
the
complex. Yes, yes.
only thing with
Actually,
the.
there is the
Mm-hmm. Mm-hmm.
mm,
Yeah,
there
proceed.
is in MEP design.
Mm-hmm.
In MEP design, most of the engineer from mechanical field, electric field, after 5 to 6 years, they have called MEP engineering, means mechanical, electrical, plumbing. Both can design. Everything can design for electrical engineer, or for plumbing or mechanical engineer can do.
Yeah, yeah,
So
yeah.
to no issue, no, and presently in presently scope of MEP design is huge. It's huge of vacancy,
Yes,
because
yes.
huge of infrastructure company, infrastructure developer also available in India. So
Yeah,
can get a more chance for an MEP design.
yeah. That's true. That's true. There are huge requirement will be there in this sector for the people,
Mhm.
so
Yes, yes.
they can choose this field also. Yeah, yeah. Okay. So if any, I mean, if big complex, big like shopping malls and all, so it will need more, right? More planning and all. It's not like a normal
Yes, yes.
house. Okay,
Yes,
okay.
yes, yes, yes. Yes, yes.
Mm-hmm.
Like hospitality, but a big hospitality, 4 point, and ITC,
Yeah,
such
yeah.
type of hospitality are required a MEP design engineer
Yes, yes, yes.
on there.
Yeah, there everything like electrically, light and lights and all also plays a major role. We have to take care a lot in those things. Yes, yes, yes.
Yes, yes.
I mean, DG set also you have to take care MEP or someone else will to took care of it.
DG set also, DG set, and a transformer, and
Mm-hmm.
building also deep panel, LV panel, LV panel and HV panel
And cabling
take
and
from
all.
MEP design.
Cabling and
Cabling
everything.
also.
Okay, okay.
And
Mm-hmm.
in plumbing sector and mechanical sector, there is the part is the HVAC system. HVAC system.
Mm-hmm.
A mechanical engineer can doing the HVAC engineering,
Mm-hmm.
and also plumbing also can
Okay.
do.
Okay. Mm-hmm. Yeah. So in electrically point of view, generally, what will be the ratings of the transformers or DG sets? Generally, we will find in typical complexes or something. Can you explain a brief idea? Uh, what will be the ratings and
Okay.
details?
Okay.
Mm-hmm.
Mhm. Actually, what is the load required for building or hospitality? So if
Mm-hmm.
I'll first finalize the what is the equipment power require power consume, such
Mm-hmm.
like in a normal building, you first
Mm-hmm.
consider the number of light points, number of socket, number of heater, geyser, fridge. First finalize the number of equipment and number of power total power of consume. After
Mm-hmm.
that, we can finalize the transformer side
Okay.
and also the actual DG have considered for emergency supply.
Yeah,
So
yeah.
sometimes actually percentage of total power have
Uh-huh.
for selection of DG set.
Okay,
So
okay.
so that and for
Mm-hmm.
transformer sizing, so some factor have considered like a diversity factor, simultaneous factors have considered for transformer sizing.
Okay, okay. Mhm. Generally, for future expansion point of view, future load point of view, how much we will consider margin? Is this
Uh,
10% or
some
20 something? How can you give brief idea?
Yes, 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 yes. Actually, HR client requirement sometimes consider 10%, 20%, not more
Mm-hmm.
than 20%, because more than 20% is initial cost is very high. So that
Yeah,
they have
yeah.
considered 20%
Uh,
maximum consider for future load they've
yeah, yeah.
considered 20% load.
Okay, okay. Mostly they are 11 kV, right? Or 3.3 or
Uh,
what? 11
Not
by
3.3, actually 11 kV to 415 volt.
yeah, yeah.
Actually, they are getting from utility 11 kV. They can
Mm-hmm.
transform by step down term. They can use the step down transformer. After that, they
Mm-hmm.
can get for 15 volt and distribute the all the
Yeah.
supply for that to the building.
Yeah, yeah, okay. Generally, when we will use 415, when we will use 433, I mean, yeah, some those two transformers are available. Can you give idea in which case we will use which one? Any idea on that?
Actually, practice about utility in India generally 415 volt use, and somewhere if you 415 volt use, then then neutral side also voltage level is 240. 240 is less than so that some as max practice 415, otherwise 430. 430 have considered you can voltage level have low. मतलब,
433, yeah,
line
generally.
yeah, so that as per practice, it is not a
Okay,
standard
okay,
actually.
okay,
As per
okay.
my knowledge.
Yeah, yeah, yeah. That's true. That depends also. Some utilities are taking. In most of the people, 433 only they will take. Where I think direct utilization is there. I mean, loads are very nearer to our transformer. For example, say your building case, your transformer is just
Mm.
in the apartment itself, maybe in the complex itself somewhere. So
Yes,
very
yes, yes, yes.
voltage drop and all. Generally, it may be very less, so I think in those cases, 415 may be good. I mean, 433 means if it is the utility transformer is maybe at the far off village, so entire
Mm-hmm.
drop may be more. So in those cases, they may be taking 433, right? What you say?
Mm, sir, actually, I got not a. I cannot get your phone actually.
Uh-huh.
Sorry.
Okay. Yeah, yeah. I think
Mm.
415 or
Mm.
433. When we will use? That's what my question.
Okay, 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 okay.
Mm.
Generally, 415 or 430 actually depend upon the utility. Actually,
Okay, okay, okay. Good,
both
good,
are
good.
same.
Yeah, nice, nice. Yeah, you given some good understanding about MEP and their engine, their working. So we will move to our substation topic. So
Mm.
let's discuss more about our substation topic. So generally,
Mm.
what is called a
Yes,
substation? We are discussing very at basic level so that anyone can
yes,
understand
yes.
easily. So
Okay,
what
okay,
is
okay, okay,
later on we will move to little bit
okay.
deeper. What is the substation?
Mm-hmm. A substation is the actually part of power system
Mhm.
which can transform the where is the transform the high voltage to low voltage or vice versa.
Yeah.
and also depend upon the power supply, continuity operation of substation. Substation is the major part of transmission, distribution and generation system
Okay.
actually.
Okay. Mm-hmm. So generally there are different types of substations like indoor substation, outdoor substation, sometimes pole
Yes,
mounted,
yes,
sometimes ground mounted like that, underground.
yes, yes.
So can you explain what is the significance for each case? In which case we will go with which one? Like.
Actually, indoor and outdoor substation has been finalized by how many area getting it provided
Mm-hmm.
for substation. So if
Mm-hmm.
you less area, low area, so you can consider the indoor substation. Otherwise,
Okay.
you can go outdoor substation. And
Okay.
up to 33 kV, we have considered indoor system because outdoor is the
Mm-hmm.
very in 33 up to 33 kV outdoor system, yeah, has expensive. So we can consider in that. After
Okay.
33 kV, we have considered the outdoor system. Or
Mm-hmm.
some has area have not available. We have considered the presently GIS system or
Mm-hmm.
hybrid technology. GIS means all equipment are SF6 gas insulated,
Okay.
and
Okay.
somewhere also hybrid technology used. Actual hybrid technology is all equipment in one compartment,
Uh-huh.
insulated from
Okay.
hybrid technology. And this practice is presently not common in India. Out of
Okay.
India, they have practiced the low area in hybrid technology, and in
Mm-hmm.
India use the SF6 GIS system for
Okay.
low area.
Okay.
That is the practice.
Yeah. Okay. So generally, from which voltage onwards we will go for GAS? What is the trend in India? Is this 66 kV or 420 kV or what? Can
No,
you?
no, not a voltage level. Actually, depend above the 33 kV, because
Mm-hmm.
up to 33 kV indoor switchgear panel is available. But
Okay.
somewhere also use the GIS system. But 11 kV system, as per my knowledge, GIS system not using 11 kV system.
Okay.
Uh, but uh, but 33 kV when voltage when current is more than 2000 3000 ampere, somewhere
Mm-hmm.
consider the GIS system. Otherwise, out indoor system also considered. But
Okay.
most of the time, above the 130, above the 33 kV, if you
Mm-hmm.
low area, you have
Mm-hmm.
considered the GIS system, SF6 gas insulated system
Okay.
actually,
Mm-hmm. Yeah,
or not is a
it is
66.
generally costly, right? SF6 will be costly, right?
Yes, yes. It is costly. It is costly. Compared to air insulated substation, it is very
Okay.
costly.
Okay.
But presently situation in area I have not available everywhere. So that
Yeah.
we have compromised the price, and we have considered the GI system.
Yeah,
So we
that's
can get.
true. Yeah, price is more costly in today's most of the cities and all. So going
Yes,
to
yes.
GAS may be good option. Yeah.
Mm.
So generally, what is the advantage disadvantage with outdoor when compared to indoor? Can you explain what is the differences? I mean, if say price is we forget about the price. Otherwise,
Yes,
because in indoor means everything may be covered somewhere. Outdoor means it
yes,
is
yes,
open to air, rain, and pollution.
yes.
Can you explain these the differences and all? I mean, uh,
Okay.
what is problems if you go for indoor? What is problems if you go for outdoor? General way maintenance and all. So can you explain?
Actually, in indoor system has small, little bit complicated and required a low area. But
Mm-hmm.
in outdoor system has a not complicated easy practice. Everywhere you can see the outdoor system, and outdoor system is not a complicated.
Yeah.
And the GIS system have a complicated, and there are number of actually require maintenance have a complicated, because there are require special area is required, and also see the area, so that it is a
Mm.
complicated, but it is sometimes it also helpful because it is not require a big area.
Yeah.
So everywhere have a advantage and disadvantage. So as
Okay.
a actually finalized, actually GIS or AI is finalized by the requirement of area actually,
Yeah.
getting the area actually area.
Okay. Mm-hmm. Yeah. Okay. There are in we have some government substations. I mean, distribution at the 33 kV line at the in villages and all. We will find some substations. So those will be maintained by discoms and all. So
Yes, yes.
yeah, what about other substations like industrial substations and all? How you people are getting? I mean, say you being in one company, you will have some customers and all. So are you having both industrial customers or private government customers or what?
Actually, working on most of the time government customer and government customer. Most of the time we are worked on
Oh.
government customer. Private customer is the sometimes actually hydro, like you
Mm-hmm.
know that some company Bharat Hydro and this Hydro, they have installed an in-house switchyard,
Yeah.
like more than actually in hydro substation is the more than 132 kV. Somewhere also use a 130 kV, but most of the time more than 130 kV are used for transmission line, for connect to the grid substation.
Okay. Okay.
And actually I have actually not knowledge about the distribution is the very low LV MV system, so I have no expertise
Okay.
in HV system,
Okay. You have more experience with
distribution
less.
system.
You are experienced with ME system, right? Medium voltage.
Yes, yes.
Around
No, no,
30.
no, no, no.
Uh,
Above the 33 kV means HV system or EHV system. Actually,
uh-huh.
distribution part is the less 33 kV up to 33 kV.
Okay, okay.
So
Mm-hmm. So from 33 onwards, almost transmission level substations, you are more experienced. Yeah,
yes,
yeah.
yes, yes, yes.
Okay, okay. Nice, nice. So there will be some different substations, for example, mobile substations, mining substations, some,
Actually,
yeah,
I have
yeah, any idea on that? I mean, in India, did we
no, no,
have,
no. Actually,
in India, we have any mobile
uh,
substation?
no, no, I have no idea about. But
Okay.
I know about science, to know about mobile. I hear it about
Ah,
mobile substation, but I have
yeah.
no
Okay,
about
okay.
the.
Because in foreign countries, most of the countries we have some mobile substations. Those are maintained by some governments in very big cities. Say, for example, New York or Washington, or in some places, they have this kind of structures. So, like that, I am asking. So, okay, no issue. Yeah, in India,
Okay,
half an hour power goes
okay.
also. It's okay. So the situations are like that. Yeah, it will
No,
develop soon.
presently
Yeah.
situation is not everywhere power available, and
Mm-hmm.
most of the actually presently grid have a more supply from most generation system, like
Yeah.
presently India focus in renewable energy, so we have not faced the such a problem because we getting the supply from more
Yes. Yes.
generation system,
Yeah.
so no problem.
Yes.
And
Yes. Yes.
actually substation designing, they have before substation design we have considered some part in keeping in mind, like how many area available, what is the voltage
Mm-hmm.
level. Actually
Mm-hmm.
after altitude change, the voltage level also insulation level have been changed sometimes, because
Yeah.
after above the 1000 altitude
Mm-hmm.
from sea level, substation insulation level also changed. So before finalize the substation layout or SLD, so we first thinking about the altitude and what is the voltage level.
Yeah.
After finalize the altitude, we have finalized the voltage insulation level. We have finalized the substation face to face clearance and also when preparing the substation layout and SLD, we first think about the face-to-face clearance, ground clearance, what is the sectional clearance. So both are such thing are depend upon the voltage level. If voltage level
Yeah.
have changed, face-to-face clearance have changed,
Yes. Yes. Yes.
ground clearance and section clearance have changed.
Yeah.
So that we have some knowledge about the clearance before
Yeah.
designing the substation.
Yeah. 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 So we have any government standards, CBIP, something like that for those.
Yes. Substation have a CVAV manual also.
Okay.
Also follow the IEC standard 61936. They have
Okay.
mentioned what is the clearance required, what is the voltage level, what is the insulation level for voltage level. They have
Okay.
indicated.
Yeah. Okay. So generally in substation, what are the components will present? Can you explain a little bit about that? What items will
Okay.
be there from starting to ending? So from supply is coming to the substation and the supply is going out of the substation. So what components we will place sequentially from one end to other end?
Okay.
So and
Okay.
their
Okay.
protection and all. So and their maintenance. Can you discuss briefly about all things?
Okay.
Yeah.
Actually, the first equipment is the inline bay set line. Inline bay, first equipment is the LA. LA is the
Okay.
major part, and LA is the first lightning arrestor. LA means lightning arrestor. First
Mm-hmm.
equipment in the substation for at line side, and
Mm-hmm.
also in power LA should be installed near the power transformer, because power transformer is the major equipment which is very expensive. So such equipment should be protected from lightning. So should install the LA near the power transformer. This is, and
Okay.
after LA in line
Mhm.
side, after LA in line side, LA CVT, and after that wire trap, also isolator, CT, circuit breaker, isolator. After that LA, and after LA connected to the transformer. And this equipment position depend upon the bus bar switching scheme. Actually,
Uh-huh.
switching scheme is different, because
Yeah.
some utility have some practice, but after voltage level, switching scheme have separate. Like
Mm.
in India, practice that single bus bar scheme,
A
double bus
double
bar
bus,
scheme, main and
one and a half bus per scheme.
and
Yeah. Yes.
yes,
Yes.
main and transfer bus bar scheme. Like
Mm-hmm.
in 400 kV, most of the practice is that above 220 kV have practice use the switching scheme bus one and a half bus breaker scheme, and
Okay.
above 66 kV like 132 kV 220 kV have double bus bar scheme, and
Mm-hmm.
double, and for 220 kV have used the double and transfer bus. Some are
Okay.
also use the for 220 kV double bus bar scheme have been considered, but
Okay.
so that for designing, for substation designing, we should knowledge about the switching scheme,
Okay. Okay.
and switch, and one of the thing is the major equipment is the circuit breaker. When you operation maintenance, actually circuit breaker maintenance is the major part of the operation of maintenance in substation.
Yeah.
So depend circuit breaker maintenance depend upon the bus bar scheme. So some bus bar scheme have not available for circuit breaker maintenance without circuit shutdown. But
Yeah.
some breaker scheme, also some switching scheme have a scope with without interruption of power supply, we can breaker maintain, like one
Yeah.
and a half breaker scheme.
Okay. Okay. Yeah. So those switching schemes purely to take care of maintenance free or like that only, right? When we will go for uh, one scheme to other scheme.
Actually,
Mm-hmm.
sorry,
Yeah, when we will go from
sorry, I
one
get.
when we will go from one scheme to other
Mm.
scheme, only to avoid disruption in power or what?
Yes. Disruption of power, and also means and system reliability, operation of maintenance. All
Oh,
things are have been keep in mind for switching scheme.
okay. Yeah, proceed. Mm-hmm.
Actually, also, and one thing is that sometimes cost also affect the selection of switching schemes.
Yeah.
Sometimes, so that for 132 kV we have considered the double bus bar scheme. We cannot consider one and a half bus breaker scheme, because for 132 kV system, if we consider the one and a half bus breaker scheme, so this is very expensive. So that not consider, there are not required the this such system. So
Okay.
most of the time, above the 220 kV, the one and a half bus breaker scheme have considered. But
Mm-hmm.
somewhere, outside of India, I have
Mm-hmm.
seen that there are 220 kV also consider the one and a half bus breaker scheme. But in India, is not practiced.
Yeah.
Presently, I have one project I have working on project in outside of India. There are 220 kV have considered the one and a half bus breaker, but that is the rare case.
Yeah.
So first thing is our knowledge about the most of the switching scheme and system reliability depends upon the switch. Fully depend upon the system switching scheme.
Okay.
And also depend upon the selection of protection system. Protection system is the different engineering. Actually, in substation design, there are two parts. One is primary engineering, other is secondary engineering.
Okay.
Primary engineering means primary engineering means preparation of SLD, layout, substation layout, plan, section, calculation. It's like. Secondary engineering means protection system, all fully protection. So both are separate thing. So primary engineer should be knowledge about the protection system. Otherwise, he cannot correctly draw the SLD. So we should knowledge about the protection system also.
Yeah, you are primary engineer or secondary engineer?
No, I am about the primary engineering actually.
Okay. Good. So you have all the everything about substation is in your mind while preparing everything.
Yes, sir.
Okay.
Yes, sir. And after finalize the SLD and layout plan, we have prepared the some others layout like direct DSLP layout, erection key diagram, layout, earthing layout. We have prepared. Also required a calculation like conductor sizing, battery sizing, and DSLP calculation and earthmat sizing also. This calculation based on the some international ISC standard.
Okay. Okay. Yeah. So up to transformer primary we covered. So you please proceed for further parts of the substation. Yeah.
Okay. And okay. And in building for such system protection system in available in the actual control relay panel in the control room building. So different actually number of panel depends upon the voltage level. Actually, some are control and protection. So some are above the 132 kV. They have control panel is separate and relay panel have considered separate. But some are also control for 132 kV. Generally, practice that both are separately considered. But some are also 132 kV, 66 kV have considered separate control panel, relay panel. But it is not a required because separate control panel means separate relay panel means it can lead to high cost.
Yes.
So up to 132 kV not required a control and relay panel separately.
Okay.
And in building there have the means equipment bay wise panel have been considered. Suppose line bay, transformer bay, bus coupler bay. If in substation have 2 line bay, 2 control and relay panel is required.
Yeah.
If 1 and 3 power transformer bay, so 3 numbers of power transformer have been required. For control and protection system.
Okay.
And one more thing is the indoor substation, up to 33 kV. There are not if indoor substation in up to 33 kV, there are not required CRP control relay panel not required because indoor switchgear panel have consider all the control system and protection system.
Okay.
So not required.
Okay.
But above the 130, but above the 33 kV, we required a separate control relay panel for protection system or controlling system.
Okay. Okay. So in substation transformer secondary side also we will have LA or what? Transformer secondary
Yes. Major thing.
Okay.
Secondary side also considered the LA.
Okay.
Because LA have put the three in substation three places. First is the in line way. First equipment is the LA, and second is the transformer HV side and LV side. Second and third, the transformer HV side and LV side have put the LA.
Okay. Okay. So what about other components from transformer secondary to the feeders and all? Can you explain about that? Generally feeders and all will be there. So secondary from transformer secondary onwards, okay. So we will say feeder, right? Or what?
Yes, yes, yes. Yes,
Yeah.
feeder also grid both three type of substation. As per power distribution, three type of substation.
Mm-hmm.
Uh, one is the pooling substation, second is the
Mm-hmm.
grid substation, third is the distribution substation. Pooling
Okay.
substation means where is the power generation, power
Mm-hmm.
generation. After
Okay.
power generation, they have transmit the power to grid substation. There is
Okay.
the most of the time voltage level is 400 by 220 kV, 400 by 132 kV. Generally
Okay.
400 by 220 kV. After
Uh-huh.
step down the 220 kV, 220 kV have connect to the distribution substation 220 by 33 kV.
Yeah, yeah,
Also
yeah.
220 by 132, 132 by 33 kV. After
Okay.
32 in distribution or transmission substation, 132 by 33 kV, 33 kV have fitted to distribute the power to consumer
Oh,
and also supply to the some places, whereas the domestic purpose or commercial purpose
okay.
supply use.
Okay. In grid substation, generally, so sometimes we will use auto transformers also, right? Or like normal transformers only.
Yes, 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 yes.
Mm-hmm. Yeah,
Most of the
proceed.
time is the auto transformer used.
400 by
Most
220 kV, all are
most of the
auto
time the
transformers.
actual grids. Yes,
Yeah.
yes, yes. Most of the time 400 by 220 kV is because after that 220 kV have transmitted to 132 kV substation, 132 by 33 kV substation, or 220 by 33 kV substation have transmitted.
Those are step down
Most of the time I
transformers.
see in grid
Mm.
substation.
Okay.
Yes, 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 yes.
Okay. Okay. Mm-hmm. Yeah, yeah. So generally, a circuit breaker means what circuit breakers we will use in substation, outdoor substations. Can you explain a bit what different types of circuit breakers are available? Which one we will choose for which purpose? Can you explain a bit?
Okay, okay.
Mm-hmm.
Circuit breaker actually generally circuit breaker is above the 133 kV.
Mm-hmm.
SF6 type of circuit breaker have considered outdoor type,
Okay.
and up to 33 kV we have considered the VCB type VCB circuit breaker,
Yeah.
and VCB circuit breaker which is the in switchgear panel, which is the indoor type
Yeah.
generally practice. But
Yes.
after up to above the 33 kV we have considered the SF6 circuit breaker.
Mm-hmm.
Recently have practiced that this is the outdoor type, and GIS system also use the in GIS system, gas insulated switching system
Mm-hmm.
substation. They have also considered the SF6 type, and
Okay.
circuit breaker actually used for in circuit for all actually used for circuit close or off.
Yeah.
Other
Yeah.
without circuit breaker we cannot power interrupt the power supply, or we cannot maintain the equipment, other equipment like power transformer, like other
Yes.
thing we
Yes.
cannot power supply, cannot sorry maintain the power
Okay.
supply. So circuit breaker is the major thing of the substation, major thing for
Okay.
protection system.
Okay. Yeah. What about isolators? Why will use isolators in substations?
Yeah, okay, okay, okay.
Can you explain it?
Actually,
Yeah.
isolator is the yes, yes,
Mm-hmm.
yes. Isolator actually used for the maintenance purpose, only for maintenance.
Mm-hmm.
Uh, Actually, sorry, if you need a circuit breaker maintenance, you need a
Mm-hmm.
isolator. After
Okay.
breaking the sorry,
Mm-hmm.
after off the circuit breaker, after that isolator have open. After
Okay.
open isolator, if you not open the isolator, and isolator have been need a arc switch.
Okay.
Arc switch is the reduce the actually charging current is reduced.
Mm-hmm.
Arc switch has the reduce the charging current. Otherwise, if you not the arc use the arc switch, when we maintenance the circuit breaker, we can get a
Stop. We can get the
shock,
shock.
get a
Yeah. Yeah.
shock.
Yeah.
So that
Okay.
isolator should record, and also record arc switch. Arc switch position also depend upon the connection.
Yeah. Yeah.
So that isolator should be required for
Yes.
main part is the maintenance purpose. Otherwise, he isolator cannot interrupt the power supply. Actually, power supply can be interrupted by the circuit breaker, but maintenance purpose of use, isolator should be required.
Okay. 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 Mm-hmm. Yeah.
And
So.
one more equipment is the CT. CT is the major equipment which can
Mm.
which can measure the current and which can protect the system by through relay. So current transformer is also major part of the substation. Most major part of the substation. Current
Okay,
one.
okay. Yeah. So what will be the output of a current transformer? Generally, what is this 1 amp or 5 amp? Generally, what is preference? Any idea on that?
Generally one of are prefer because in HB because you know that resistance if you 5 ampere have considered secondary side have a resistance have a burden have been increased, so that if you read minimize the burden, so most of the time we have considered 1 ampere most
Okay,
of the time.
okay, okay. Yeah, yeah. So what about potential
And
transformers? PT,
potential the actual
PT,
PT is yes, yes, yes,
voltage transformers. Yeah,
yes. Yeah, I can understand.
yeah.
PT there is the two actually voltage transformer is two type of are in use. One is potential transformer, one is capacity voltage transformer. PT means inductive type,
Yes,
and
yes.
capacity voltage transformer they are used. Generally, potential voltage transformer is the expensive up above the 66 kV. So.
Uh-huh.
Uh,
Okay.
most of the practice that CVT have been used for the above the 66 kV because due to
Okay.
cost, PT not considered. PT actually used for the protection, also part of the protection and also measure the voltage. So
Yes,
PT is
yes.
the major also a major part of the substation.
Yeah,
And
yeah.
PT have been PT position is depend PT is required for bus matlab means bus bar, and also also located at incoming bay, outgoing line bay. So PT have been considered. But
Okay.
in 33 kV, PT is not required for for a line. Sorry, for a line, not
Okay.
PT is required. But
Okay.
above the 33 kV, PT is required uh, for
Okay.
line side.
Okay. Okay. Yeah. Okay. So is in substation, is there any energy meter like that for reading entire outgoing power or incoming power? Any reading like that or what?
Yes. In tariff metering means you call the energy meter. Some are called energy meter. Energy meter actually put the lines after the LA or CBT, tariff meter or energy meter have put for power
Okay.
tariff system.
Okay.
Generally, tariff meter are put in the generation substation. Some are power independent feeder have power taken from substation. There
Okay.
have also considered the energy meter
Okay.
or tariff meter have considered.
Okay. Okay. Yeah.
And
So
LV side,
yeah,
yes.
proceed.
Yes, you can proceed. Yes.
Okay. So whatever the bus bars or conductors are there, generally overhead conductors means aluminum in most of the transmissions. So what conductors we will use in a substation? Is this copper or aluminum, or it is rectangular bar, or it is normal round conductor, or sometimes I seen halo also. Can you explain a bit what we will use, which condition, which material about that?
Okay.
Mm-hmm.
Actually, in substation, three bus are available. Three bus bar system. One is main bus, other is jack bus, other one more is the equipment bus. So
Okay.
depend upon the voltage level and depend upon the current actually. And
Mm-hmm.
generally aluminum bus bar are used. Aluminum
Okay.
type of aluminum or ACSR type of conductor have been used in substation
Yeah.
generally.
Yeah.
Otherwise, aluminum tube use.
Mm.
Copper is a rare case. Not used. I have not seen the copper busbar or copper tube not used in outdoor substation.
Okay, okay,
Generally,
okay,
type of conductor and conductor type is different. SCSR is the type, and there have a different conductor like moose. You know the moose, zebra,
yes,
or panther,
yes, yes,
dress means such type
yeah,
of conductor have been used. and actually current carrying capacity have the more is more than copper tube. Tube is the current carrying capacity more than conduct means aluminum ACSR. So some are voltage, some are require high voltage and current also high. So there are used the generally tube,
Okay.
aluminum tube, not use the copper tube. Aluminum tube have considered generally.
Okay. Okay.
We have
Yeah. Nice.
considered, and in line side also aluminum ACSR conductor, triple AC conductor have used
Mhm. Yeah. Yeah.
generally.
Yeah, one thing, what are those names of conductors? Panther, zebra. Generally, I seen connector types, whatever connectors are there at the transformer, connecting overhead lines and transformers. Those connectors also we have different names like that. So, what is those names? Can you explain a bit about the? Is this based on
Okay,
capacity
you
or what? Yeah.
okay.
Mm-hmm.
Actually, connector you said that you told that like expansion type or easy type. This type of
Mm-hmm.
connector actually
Mm-hmm.
depend. Actually, if you consider the tube conductor, if you consider tube conductor, so on this in such condition in tube condition, so expansion type connector or rigid type connector are considered. Otherwise,
Mm-hmm.
conductor means ACSR conductor have considered. You consider the terminals aluminum type of connector.
Okay.
And this isolator have all equipment have the required a connector, and
Mm-hmm.
like in isolator have a required connector, CT have a required connector, terminal connector also required, and
Okay.
the terminal connectors are like a T type connector, PG clamp, T clamp have considered for the connection of conductor.
Yeah. So what about these different
Okay.
namings? Panther, zebra. Well, we have different namings, right, for the conductors and all. What about that?
Yes.
I mean, when we will use zebra.
Actually, depend upon the current carrying.
Uh-huh. Okay.
Actually, they have
No,
actually
no.
in the
Yeah,
actually this
yeah. Proceed.
is the actually practice actually as per the standard have finalized the actually if you not indicated any name, so you cannot which conductor have the carrying the which hot current. So they are defined the name. So we can told not that 340 ampere is required. So we cannot the 340 ampere conductor. So that indicate that such type of conductor have name, they have given the name. So we can call that name. Though we can understand that this conductor can carry such current.
Okay.
This is
Yeah, got it. Yeah. Okay, so what about this DSLP, direct stroke lightning protection? I mean, what
the
we will do for the direct stroke lightning protection? What items we will consider? So calculations means what
for
we,
the
yeah.
actually for DSLP means direct stroke means from cloud to ground stroke. So direct stroke, and this direct stroke can affect the substation. So we should protect the equipment from direct stroke lightning.
Okay.
So for direct stroke lightning protection, for we have considered the shield or otherwise lightning spike. We have
Okay.
considered,
Okay.
and we have
Mm-hmm.
considered, and this calculation depends upon the based on the IEC standard triple IEC 998, or other method also have considered is the Rajving, generally called Rajving method practice. So
Mm-hmm.
there, as per calculation, we have finalized the how many, where is the shield wire required, where is the spike gas required. So as per calculation, we have finalized the
Yeah.
uh, position of lightning spike or shield wire, which can protect the equipment actually.
Yeah. Okay. Yeah, we have like a rod lightning arrestor type will be there.
Called- yes, it's called spike, lightning spike.
Spike. Okay. Yeah, sometimes
Yes,
we will protect the space also, like zonal protection. What about that? I mean, in this
yes,
angle,
yes.
what about is this both spike
Actually,
protection
angle
both are
have
same? Yeah. What
yes,
about?
yes. Actually, presently angle method have not considered. Presently, are doing the this called is the Rajvik method. or rolling span method. Both are use the same lightning spike use, but they have calculation is separate.
Okay.
And this is the cover the area radius. Actually, they are actually told that zone means
Yes, yes.
area how many radius has cover.
Yeah,
So
yeah.
we get a radius from the calculation. So after
Mm-hmm.
getting the radius, so how many spike have or must have required to finalize. You finalize the number of spike or number of position of spike.
Almost entire substation we have to cover, right? That area, that radius, based on entire
Yes,
substation.
yes.
Yeah. Okay.
Yes. And in substation design, also one more thing is a cable trench. Cable trench drawing is required for
Yeah.
preparing the cable or the cable position. Cable laying location actually is required for cable trench for substation designing. Cable
Yeah.
trench drawing also required or
Yeah.
cable trench also required.
Okay.
Actually,
Okay. Yeah. 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 So generally, what type of cables we will use in substation? I mean, from where to where
the
cables
power
are?
control
Because most of the times
control.
only control related
Yes,
we will
yes,
use cables, right? Not for power transfer.
yes. Only control related cable actually.
Okay. Yeah, yeah. Because somewhere I read that in substation incoming and outgoing lines, at least for some distance, we will use cables for protecting surge impedance and all. Did you have any idea on that? At incoming or outgoing side, we will use some cable in the power transmission itself. Did you have any idea on those things?
Actually, not to get your point. Actually, I did
For
not get your point.
example, substation incoming, we will have one overhead lines,
Mm,
right? Simultaneously, substation
mm.
outside also, outgoing feeder also will have some overhead lines. At the starting or end, we will use some cables instead of overhead lines. Overhead lines to cable they will connect. That cable will goes to the substation, something like that. Instead of conductor, they will
Okay.
use cable.
In on overhead system.
No, in not overhead. At the substation, nearby substation, they will use maybe 1 kilometer, something like that. They will use this kind of cables instead of overhead
Okay.
system.
Okay. But
Okay.
this first type of system I've considered for the distribution part, distribution 33 kV system, where is the not put the overhead pole means pole. So we have considered the cable underground system, underground cable.
Okay.
We have
Okay.
considered.
Mm-hmm. Yeah. Okay. Okay. Good. Good. Most of the components we covered in substation. Yeah.
Yes.
Mhm.
Yes.
Yeah. Yeah. Okay. Mm-hmm. So what about other measuring devices in the substation? Apart from CTPT, what components will be there measuring instruments in substation?
Okay. In
Mm.
substation, actually measuring part is the by the CT or PT.
Okay.
Other device I have no knowledge about that.
Okay. Okay. Yeah.
So
No issue. Yeah. Is isolator disconnector both same or different?
yes. Both are same. Some are called disconnector, some are called isolator,
Okay.
and they have just international number also.
Mhm.
Maybe 89. They called the isolator. Some are
Yes.
indicated
Yes.
the
Yes.
89,
Yeah.
uh,
Yeah. Yeah.
and circuit breaker also indicated the 52.
ANSI configuration, right? ANSI numbering.
Yes. NSI number. Yes.
Yeah, okay, okay. So we covered most of the topic. Now, some your work experience related. You, I think, around 5, 6 substations you finished. So, what's your experience? For example, at Kundli substation, what's special in that in Haryana? So that I think two transformers are there in that substation, 132 by 33 kV.
Yes.
40,
Yes.
40,
Yes. Yes.
40 bar by 50 MVA. So if any
Yes.
fan rating is there, what is your considerations? Any special things you will take care in the substation or what? Forced cooling is there means.
Okay, for power transformer, there is the 132 by 33, 40 by 50. Means
Mm-hmm.
ONF by ONF and OFAF
ONF.
have considered.
Mm-hmm.
Yes.
Okay.
Have considered
Mm-hmm.
for power transformer. Actually, this is the distribution substation 132 by 33. After 33, a power transmitted to the domestic purpose or commercial purpose.
Okay.
And
Okay.
this substation is the Haryana State Utility Substation. And there is the number of bays the more than 132 kV number of bays the more than 10 numbers.
Okay.
And this
Okay.
is the and there have a so in major thing is the in power transformer. There is a depend now current carrying capacity, current density, flux density. When review the equipment,
Yeah.
when you review the power transformer, we should be must knowledge about the what is the flux density, what is the current density is required. This is a
Yeah.
major thing of the power transformer.
Okay.
So we have faced that one thing is the for current density principal tapping or current density however is the fix the current density at
Yeah.
principal tapping or not or low rating tapping. So this is the effect the our side also affect the current also client side. So we finalize the after that principal because if you consider the lower side, so obviously transfer cost will be increased. So
Yeah.
this is the
Yeah.
one thing I can teach from learn from thing
Okay.
from a fully substation designing.
Yeah. What about paralleling or parallel connection? I mean, paralleling of transformers. Did you done anything like that in substations, two transformers in parallel, or what? Any idea on that?
No,
Okay.
no, actually, not
Okay.
doing this
Okay.
software.
Okay. So I think I'm another substation. It is in Assam. That substation may be a little bit higher altitude, right? Assam
No, this
substation.
is also below the below the 1,000 meter. This is
Okay.
also below the 1,000 meter. So no altitude factor have not considered.
Mm-hmm.
After altitude more than 1,000 meter, so altitude factor have considered and voltage insulation level actually have changed and
Okay.
face to face clearance also changed.
Okay. Okay.
But actually I have not a such type of
Yeah.
project
Yeah.
not worked still
Yes. 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 I
actually.
understand. Yeah. Yeah. Okay. So what's your experience at this GA substation, Noida? So
Mm,
have you worked on it, or it's still going on?
no, I have actually partially I have not fully worked on the GIS substation actually. Partially worked. There actually major thing is the preparation of layout, SLD, building and cable schedule. I have
Okay.
done,
Okay.
but
Okay.
other thing I've not done.
Okay. Yeah.
Okay.
We have a firefighting system also, NIFPS, the nitrogen injection system and all. Did you have any idea on that? Generally, what is that? Why will you use that? So
Actually,
how it will operate? Any idea?
no. Actually, this part is the firefighting engineer actually.
Okay.
So I
Okay.
also actually we have not in-house design the NIFS design
Okay.
NIFS design from other outside of.
Okay. Okay. Nice. 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 Yeah, Nanda, we covered many topics today. So many topics. Yeah, it's very nice.
Okay.
We it's
Yes.
almost, yeah, we almost come discussed for 1 hour. Very good.
Okay.
Nice discussion. You shared all your experiences initially about MEP and about the substation and all. Yeah, very good. So we are going to do many more videos also in future. This is not the end. This is
Yes.
just,
Of course.
yeah, this is just a
Yes.
starting. So in
Yes.
future, for example,
Mm.
earthing related, what different types of earthing is there, how we will
Yes.
consider, what conductor
Yes.
material you have to choose, earth mat means what. I mean, so many things about earthing. I want to conduct one interview on that. So in next video, our topic will be on earthing related. Every earthing, it may not be
Oh,
about substation. It everything earthing
yes.
related. It household earthing, substation earthing, transformer earthing, whatever earthing is there. You try
Mm.
to, yeah. This discussion is only a normal discussion, but for that earthing,
Yes. I understand.
you try to
Mm.
prepare any presentation if possible, PPTs kind of thing in PPT document.
Okay. Okay, okay, okay. I will try. I will try,
Yeah,
and I will
yeah,
prepare the
yeah,
document for earthing system.
yeah,
Because earthing part is a major vast part.
yes, yes,
That is the major thing.
yes,
Only
yes,
substation earthing, building earthing, control
yes,
room building earthing, equipment earthing, different earthing is required. Earthing system,
yeah.
earthing, very vast
Yeah,
thing.
I will schedule a call for that in February. In one day, I will plan that.
Okay,
Yeah, you please
okay,
prepare a PPT for that. We will discuss it. Thank you,
okay,
Nanda, for
okay.
today's discussion. Very nice. Yeah,
Thank you
yeah,
for giving such privilege, and also wish you good luck for the such initiative which can help to our electrical society. This is a very good initiative.
yes,
Thank you for
yeah. Nice, nice, nice. Good, good. Yeah. Bye. Take care. Yeah.
thank you.
Thank you, friends. This is about a substation interview with Nanda. He is very energetic guy. So we are going to plan many more videos also with him in future. So I hope you enjoyed this content. Thank you. Thanks for watching. Please subscribe to my channel so that you don't miss any of my future videos, and you will get notifications when I'm posting it. Thank you. Thanks for watching. Bye. We will meet in next video.